Okay, hi everyone. So now we are going to look at into explosives. So previously we have looked into arson. So what is the definition of arson? What is the triangle of fire? Okay, and then we have looked into what do we do when we need to search during an arson investigation, and then how are we going to collect and preserve the evidence, right? So now we are going to look at into explosives. So basically, explosive is a growing threat, right? So explosives, such as uh, explosive caused by a bomb. So usually it is a growing threat. This is by the act of terrorism. So basically, what is terrorism? Okay, terrorism with non-exact definition. There is no exact definition for terrorism, but it is an unlawful acts of violence with disregard to the safety of civilians with the intent to create fear for their senseless ideology, right? So usually bombing was always the chosen item as the method of terrorism, as this act of terrorism often happens in public spaces and cost the life of the innocent, right? So, based on the data of by the Global Terrorism Database, so usually uh, the terrorism is acted by bombing. About 57% is by bombing, right? For armed assault, it's about 31% here, right? So basically, the use of explosives as the act of terrorism is a growing threat to our country or even to the world, right? Due to their senseless ideology. All right, so let's look at an example of bomb incident in Malaysia. So I believe that all of you have heard about the Mongolian model shot and blown to bits, which is near Puncak Alam, which is exactly near my house actually. All right, and then yeah, they have been using C4 bomb to bomb Altantuya, right? So this is something that's very interesting for you to read, right? For you to get a little bit of information on what they did to and what did they use to bomb this person, right? All right. In 2013, also we have looked into the Boston Marathon bombing. Okay, it happens where there is a lot of people that's concentrated in one vicinity, right, during the marathon, of course. So when people have apa, berkumpul dekat tepi jalan untuk tengok orang marathon, so the bombing happens. So this is where we looked at into their senseless ideology. What is the motives? Kenapa dia orang buat benda tu? Sebab dia nak cause fear. Okay, but it also cause the innocents' lives as well, right? Okay, so this is an example of a bomb device. So these are the anatomy or the things that is important in a bomb initially, right? So you need to have your explosive, you need to have your initiator, your power source, and your switch. So basically, let me remind all of you, this is for learning purposes only, because you in forensic science you need to know about these things, right? So use your knowledge wisely just for learning purposes, for you to be able as a forensic scientist to know on what to look for. Okay, all right. So an example of a bomb is a pressure cooker bomb. All right, so this also might be I will put this inside the forum as well for you to be able to create some sort like a paragraph of what is a pressure cooker bomb actually. What did the how is it called a bomb, right? So this will be considered as your attendance for explosive lecture, right? Okay, so motives for bombing, senseless ideology. This is for you as well to be able to, to know about what is their senseless ideology. because for arson, we have a lot of motives, isn't it? So we have a lot of revenge motives, even acts of violence. All right, so you need to know on what is the motives for bombing. Yes, it is a senseless ideology, but in what terms? Okay, so you need to know this as well. All right, let's go to the definition. Okay, an explosive is a reactive substance that can produce explosion. Okay, an explosion is a rapid increase in volume and release of energy in an extreme manner. Okay, usually this release of energy will be in terms of high temperature, light, and also gases. Okay, so basically, when a bomb has been detonated, so there will be suddenly a build-up of gas pressure. So this gas pressure would create a shock wave. Okay, I believe that if you want to see this clearly, you can look. I think recently there is a, if I'm not mistaken, the Beirut explosion. Okay, the Beirut explosion whereby the bay, if I'm not mistaken, that the shock waves has been felt. I think about 10 to 12 kilometer outside the radius of the explosion, right? Okay, so let's look into the type of explosion. This is very important. Okay, if the shock wave is subsonic, the oxidation reaction is called a deflagration. Okay, the source of explosive for this material, the source of explosive material for causing deflagration is, we call this as low explosive. But if the shock wave is supersonic, and the oxidation we call it as detonation, then the explosive material is said to be high explosive. Okay, all right, so let's look into what is low explosive and what is high explosive. So low explosive, the most widely used are black powder and smokeless powder, right? So black powder is a mixture of potassium or sodium nitrate, charcoal, and sulfur. So because it burns slowly, it is often used as a fuse to a high explosive. So usually this low explosive would be a domino effect for a high explosives things because it burns slowly, right? So smokeless powder usually contain nitrocellulose, which is a plant fiber with the presence of sulfuric acid or nitric acid. So it is more stable yet powerful, all right? Okay, that is low explosive. Now we look at high explosives. High explosives can be characterized by their sensitivity in terms of impact, heat, and friction. Right? Primary explosive are highly sensitive, secondary fairly insensitive, tertiary is the least sensitive. Okay? Primary explosives, which is the highly sensitive one. Primary explosive provide the major ingredients found in blasting caps or primers used to detonate other explosives. So in this case, maybe it is in terms of nitroglycerin, lead azide, and mercury fulminate. Okay, that is high explosives. Secondary explosives, which is the fairly sensitive, sorry. Secondary explosive will normally use as the main charge of the bomb device. So usually this will be in terms of dynamite, trinitrotoluene TNT, all right, RDX and PETN, all right. Okay, let's look at the tertiary explosives. Tertiary explosive, or we call it as blasting agents, are so insensitive to shock that ignition by both primary and secondary explosive is required. So now in terms of explosive, high explosive, you need to have the primary, secondary, and tertiary. So if you have tertiary explosives, it is so insensitive in terms of that you need the primary or secondary to make it detonate as well. Okay, so primarily used in large-scale mining and construction and in terms of terrorism lah. So ammonium nitrate or fuel oil. So usually tertiary explosive might be the least sensitive one. Okay. Okay. So now we are going to look at into the steps in terms of explosive trains. All right. So we have two step, four step, sorry, two steps and three steps and four steps in terms of the explosive trains, right? So you can look at this figure where there is an electric blasting cap. Now we will have a primary high explosives, which is the most sensitive one, right? And then you have your dynamite here, which is your secondary high explosives. So it is the combination of primary and secondary. What about the three-step explosive train? So usually we have a low explosive here, which is the black powder, and then we have a primary explosive and the secondary high explosive. What about the four-step? So the four-step usually it combines everything: low explosive, high explosive, primary high explosive, secondary and tertiary high explosives. So these are maybe the building blocks of an explosive. All right. So when you have arrived at the crime scene, at the explosion scene, so what do you do? Okay, what do you do at your scene? So always assume there is a second or undetonated bomb present at the scene of your explosion. Never approach the scene of explosion until the safety of the place has been confirmed by the bomb disposal team. All right. So when you arrive at the scene, this is the number one precaution for all of you to bear in mind. It is different from arson. Arson, as long as you've got the flame down, you need to straight away go to the to to where the burning starts, okay, to collect the evidence. But for explosion, you need to be able to know that there you need to bear in mind that there is always a second or undetonated bomb must be present at the scene of explosion. Never go without getting the green light from the bomb disposal team, right? So how do you search for at the explosion scene, right? So basically, usually we have a canine team. Okay, so this dog that has been trained to identify the explosive by sniffing out the vapor, as what as before this we have looked into arson. The sniffing dog can smell to part per trillion, if I'm not mistaken. All right. So high in maintenance stands for distraction, physiological boredom for and the handler. All right. So usually we have canine team and also X-ray imaging. Okay. So for X-ray imaging, it detects any prohibited items from passing the security line. Okay. But the weaknesses for this X-ray imaging, it cannot penetrate high density material where the complexity due to the complexity of the image. Okay. All right. Okay, so now we are going to look at into an instrument for you to be able to bring to the scene, which is called ion mobility spectroscopy. Okay, it interacts between matter and electromagnetic radiation where from the vapor of the explosive. Okay, the advantage of having this ion mobility spectroscopy, it is high selectivity and sensitivity, sorry, towards the explosion scene. Okay, so usually it it needs it is a big size. Okay, it exists in a big size and quite expensive. But if you do have this, then it will be good for you because of its high selectivity and high sensitivity towards the vapor of the explosives. So usually this is the schematic diagram of your ion mobility spectroscopy. Okay, so your sample, your vapor from your explosion scene would go into this ionization chamber where it will be subjected to electric field in the drift region, and then it will be detected by the detector. Okay, more or less lah, you need to know in terms of so we need to have a canine team. Why? We need to have X-ray imaging also, and also we need to have ion mobility spectroscopy. Even though this is quite expensive and quite big in size, but having it would create some much more easier for you, right? Okay, so the entire explosion site must be systematically searched with great care given to recovering any trace of detonating mechanisms or any item foreign to the explosion site. Okay, the blast location or center of the blast must be discovered and approached with extreme steps of precaution. So now you will imagine that when you have a explosion site, it may lead to a certain radius. So basically, we also need to work from outside towards inside. Okay, so usually we will see how does the what is the radius of the detonation, then we will work from that. Okay, because we need to ensure that we recover any trace amount, any trace detonating mechanisms present at the site of the scene. All right. So how do we do this? Potential sources of evidence. So you need to look for IED fragments in terms of look for the container, the igniter, the fuse, or any undetonated residue. Okay, that is in terms of the bomb fragments. Okay, so we also need to look into the solid or porous materials between the vicinity of the explosion in terms of wood, cloth, upholstery, rubble, or glass. Maybe there is some explosive residue that has been that has been absorbed by all of this solid or porous material. Okay, we also need to look for human parts in terms of skin or hair, okay, whether there is a person at the vicinity, uh, because in case of Altantuya, you can find the body parts, I think about few hundred meters away from the detonation site, okay? All right, surrounding sources in terms of soil, water from the puddle. So usually, if there is a puddle of water near to the detonation site, so usually it will contain some explosive material as well, or even so, any other material in terms of maybe the perpetrator or maybe other relevant evidence. Okay, post blood samples are collected and often placed in a sealed airtight container. This is the same as what we have looked in arson. Okay, soil or soft material in the form of powder can be stored in a ziploc or plastic bags, but this is not the case for arson. Arson, everything need to be in a sealed airtight container, but no plastic bags, right? All right, metal debris or any sharp material should be wrapped in a protective material in order to prevent it piercing the container. If there is a liquid sample, it must be collected in an amber glass container. So this goes without saying lah. Usually, amber glass will be the choice because we would like to minimize if there is a substance which is prone to oxidation by sunlight. Okay, so what are the challenges when you when you arrive at the scene? So massive explosion usually leaves traces amounts of evidence as compared to small explosions. You might look at a very large radius, explosion radius for a massive explosion as compared to small explosion. So your scene, your crime scene, your explosion scene will be much more bigger, and much more people would be required to scour the scene to find evidence. Only a small fraction of sample remains after detonation and combustion process. So this is also goes without saying. So as it as the explosion site is very large, then um, it will be much more harder for you to collect the evidence. Okay, evidence also tends to blend into the surrounding. So usually, if the scene is quite large, involve a few hundred meters, then I think that you will need to have a lot more of people in terms of to find the evidence, because the evidence might be hiding somewhere inside the vicinity of the explosion area. All right. So explosive sample analysis. So what are you going to do when you have found an explosive evidence. All right. So in terms of forensic, usually okay. So for forensic explosive residue analysis, it will be related to post-explosion products for bombing activities by the terrorists lah. Right. So proper forensic analysis must be carried out for the evidence that has been collected. Okay. Evidence collected can be the ultimate use in court. Okay, so whatever evidence that you've got, you need to ensure that you preserve the integrity of the evidence, because that is the only thing that is going to be used in court. All right. Typically, in a laboratory, the debris collected at the explosion site usually will be examined microscopically. All right. In terms of the organic the recovered debris also can be tested by using TLC, thin layer chromatography, HPLC, and also GCMS. So, if you were to look into the explosion, TNT, the black powder, so you can use all of these instruments for your analysis. Okay. So basically what we have learned during these two lectures, so we have defined what is arson and explosives. We have learned also the basic of chemistry of fires. We have described on how are you going to search, collect, and analyze the arson and also the explosion crime scene. Okay. You also have looked into the differences between low and high explosives. In terms of high explosive, you have primary, secondary, and tertiary explosives. What are the explosive trains? What is it composed? 2-step, 3-step, and 4-step, right? Describe the method of evidence collection. How are you going to collect the evidence? How are you going to preserve the evidence, and what are the limitations or challenges in arson and bombing cases. All right, so I think that's it for arson. Thank you.